Product Introduction. This video uses the CP34T1 positioning kit as an example to demonstrate how to build a complete LoRaWAN network from scratch. If you are using a CP32 related kit, you can also follow this tutorial to complete the same gateway deployment and device onboarding process. For detailed information, technical documentation, or solution support regarding the CP34 and CP32 series products, please contact us via email. In this video, the functions of each device are as follows. The LoRaWAN gateway acts as the bridge between end devices and the network server. It collects data transmitted by end devices and forwards it to the server, while also sending server commands back to the devices, enabling seamless two-way communication. CP28 beacon can be deployed in individual rooms such as offices and meeting rooms, serving as a fixed anchor point. CP34 master acts as the core positioning device at the floor level, responsible for collecting and aggregating positioning data within its coverage area. CP35 beacon is used as an asset and cargo tracking tag and can be attached to equipment, tools, goods, and other assets. CP29 beacon is used as a personnel positioning tag and can be worn by employees, visitors, or field operators. Before we begin the configuration, let's take a quick look at how the LoRaWAN system works. Multiple beacon devices periodically transmit their status information and sensor data through Bluetooth advertising. The CP34 master scans and collects these Bluetooth broadcasts from nearby beacons, then aggregates and processes the received data. Once the data collection is complete, the CP34 master transmits the processed data to a LoRaWAN gateway via LoRaWAN wireless communication, enabling long-range and low-power data transmission. The LoRaWAN gateway connects to the Things Network Cloud platform through either Ethernet or Wi-Fi. Within the TTN Cloud platform, users can centrally manage gateways and end devices, perform device registration and network joining, as well as receive and forward data. Users can log in to the TTN platform from a computer or mobile device to monitor uploaded data and communication status in real time. The gateway included in this kit operates on the 915 MHz LoRaWAN frequency band by default. If you require a gateway with a different frequency band, please contact our support team for assistance. Please note that the LoRaWAN gateway itself does not process application data. Its primary role is to forward data packets from the CP34 master to the TTN network server. Next, we'll walk through the process of setting up a LoRaWAN network. The procedure consists of three main steps. To get started, open your browser and navigate to the official TTN website. On the home page, click the Sign Up button located in the top right corner. You'll be presented with two registration options. The Get Started for Free option on the right is designed for TTN commercial services and enterprise deployments, which may include paid feature. For this tutorial, we'll choose Join the Things Network on the left to create a free TTN Community Edition account. Next, click Sign Up for Free and follow the on-screen instructions to create your TTN account. Once the registration is complete, return to the TTN homepage and log in with your newly created account credentials to continue the setup process. Once you're logged in, click Console in the upper right corner to open the TTN console. The first time you access the console, you'll be asked to choose a server cluster, such as North America 1. After making your selection, you'll enter the management interface for that cluster. Keep in mind that you must use the same server cluster for future logins. Gateway registration, device registration, and all data communication must also take place within the same cluster. Otherwise, the gateway and end devices will not be able to communicate with each other. With the TTN cluster selected, go to Gateways in the left side menu and click Register Gateway. Enter the Gateway EUI, then click Confirm to continue. You can typically find the Gateway EUI on the label located on the back of the gateway or in the product datasheet. After confirming the Gateway EUI, you'll be directed to the Gateway Registration page. Let's take a look at the key settings. First, Gateway ID is the unique identifier of the gateway and must be unique within the same tenant. If errors occur, you can modify it according to TTN's naming rules. Keep in mind that a deleted gateway ID cannot be reused. Next, gateway name is used for device identification. You can assign a name based on your needs, or simply leave this field blank. For frequency plan, select the option that matches the frequency band supported by your gateway. For example, in the United States, choose United States 902 to 928 MHz, FSB2. The remaining settings can be configured according to your deployment requirements. For more information, refer to the TTN documentation. Once you've completed the configuration, click Register Gateway to finish the gateway registration process. Once the gateway has been registered, navigate to API Keys in the left side menu and click plus Add API Key to create a new API key. You can keep the default permission settings or modify them to suit your application requirements. After reviewing the configuration, click Create API Key to generate the key. When the API key appears, copy it and save it immediately. For security reasons, TTN displays the full API key only once. After you close the window, the complete key can no longer be viewed. Make sure to store the API key in a secure location, as it will be required during the gateway configuration process. With that, the gateway registration and API key setup on the TTN platform are complete. Next, let's access the Gateway Management Interface. The gateway provides two access methods, Wi-Fi AP mode and Ethernet access. Depending on your deployment environment, you can use either method to connect to and configure the gateway. Please note that the LED indicators may behave differently across gateway models. In this tutorial, we will use the RAK7268 gateway as an example. If you are using a different model, please refer to the corresponding product documentation for the actual indicator definitions and operating instructions. Let's start with the Wi-Fi AP access method. Power on the gateway and wait a few minutes for it to boot up. When the status LED begins flashing with a slow breathing pattern, the gateway startup process is complete. Using a PC with Wi-Fi capability, open the list of available wireless networks and locate RAK72XX_YYYY. In this network name, RAK72XX indicates the gateway model, and YYYY represents the last four digits of the gateway EUI. Connect to the network, then open a web browser and enter 192.168.230.1 in the address bar. This will take you to the Gateway Management Interface. If a security warning appears in your browser, click Advanced and continue to the website. Next, we'll use the Ethernet access method. Once the gateway has finished booting, connect an Ethernet cable between the gateway's WAN port and your PC. Open a web browser and enter the gateway IP address in the format 169.254.x.y to access the Gateway Management Interface. The values of X and Y are calculated from the last 2 bytes of the gateway EUI. Simply convert the last 4 hexadecimal characters of the gateway EUI into decimal values to obtain the corresponding IP address. For example, if the last 2 bytes of the gateway EUI are 8620, hexadecimal 86 equals 134 in decimal, and hexadecimal 20 equals 32. The resulting gateway IP address is 169.254.134.32. If a security warning appears in your browser, click Advanced and proceed to the website. Once connected, you'll have access to the Gateway Management Interface, where you can continue with network setup and LoRaWAN configuration. Next, we'll use the Wi-Fi AP access method as an example to configure the gateway for LoRaWAN operation. The first time you access the Gateway Management Interface, you'll be asked to create a login password. After the password has been set, you can sign in using the default username, root, along with your configured password. Once you've logged in successfully, select the appropriate country or region according to your deployment location. After completing the basic setup, click the second option in the left side navigation menu to open the configuration page. Under Work Mode, select Basic Station. Then configure the server connection as follows. For Basic Station Server Setup, choose LNS Server. For server URL, add the prefix WSS://, then paste the URL copied from the TTN console. For port, keep the default value of 8887. For authentication mode, select TLS Server and Client Token Authentication. Under Trusted CA Certificate, upload the ISRGRUTS 1.PEM certificate included in the product package. You can also download this certificate from the RAK Documentation Center. For Client Token, enter the API key that you created earlier in the TTN console. Once all parameters have been configured, click Save Changes. After a few seconds, a success message should appear at the bottom of the page, indicating that the gateway configuration has been saved successfully. After completing the LoRaWAN configuration, the next step is to connect the gateway to the network. A working internet connection is required for the gateway to communicate with the TTN cloud server. The gateway supports both Wi-Fi and Ethernet connections. Simply choose the method that best suits your deployment environment. Please note, the behavior of the gateway status LEDs may differ depending on the model. In this tutorial, we use the RAK7268 gateway as an example for reference. Let's start with the Wi-Fi connection. In the gateway's web interface, click the third item in the left navigation menu to open the WAN page. Then, under the Wi-Fi section, click Settings. Next, click Enable to activate the Wi-Fi interface. A pop-up message will appear. Click Close to dismiss it. Wait a few moments, or reconnect to the gateway's Wi-Fi and refresh the page to apply the updated configuration. Once the page has been refreshed, click Scan to search for nearby wireless networks. Select the Wi-Fi network you want to connect to, enter the password, and click Save to apply the settings. Close the pop-up message, and wait for the gateway to establish the network connection. When the gateway status LED changes from breathing green to solid blue, the Wi-Fi connection has been successfully established. Next, let's look at the Ethernet connection. Connect one end of an Ethernet cable to the gateway's WAN port, and the other end to a router, network switch, or other upstream network device. The gateway will automatically obtain a network connection. When the gateway status LED changes from breathing green to solid blue, the Ethernet connection has been successfully established. After completing either the Wi-Fi or Ethernet network configuration, the gateway will be able to connect to the TTN cloud server over the internet. You can then verify that the gateway is online in the TTN console. Once the gateway has been configured and successfully connected to the TTN cloud server, the next step is to create an application and register your LoRaWAN end device. In the TTN console, select Applications from the left navigation menu, then click Add Application in the upper right corner. Enter an application ID according to your requirements, then click Create Application to complete the setup. Please note that the application ID must be unique within the same tenant. Once an application ID has been deleted, it cannot be reused, so choose it carefully. Next, let's register a LoRaWAN end device. Open the application you just created, select End Devices, and then click Register End Device in the upper right corner. Select Enter End Device Specifics manually, then enter the device information as follows. Set frequency plan to match the frequency plan used by your gateway. Set LoRaWAN version to LoRaWAN specification 1.0.2. Set regional parameters version to RP001 regional parameters 1.0.2. For Join EUI, also known as App EUI, send the AT plus App EUI command through the serial port or the mobile app to retrieve and verify the value. For Dev EUI, send the AT plus Dev EUI command through the serial port or the mobile app to retrieve and verify the value. For App Key, send the AT plus App Key command through the serial port or the mobile app to retrieve and verify the value. You can customize the end device ID as needed, but it must be unique within the same application. After verifying that all the information has been entered correctly, click Register End Device to finish registering the end device. Next, we'll demonstrate how to connect a LoRaWAN end device to the network using OTAA with the CP34 master as an example. First, attach the antenna, connect the power supply, and press the power button. The device will automatically begin its self-test. During this process, all three status LEDs will flash rapidly at the same time. Once the self-test is complete, the device enters network join mode, and the red LED will flash rapidly, indicating that it is waiting to join the LoRaWAN network. By default, the CP34 master is configured to join the network automatically. After the self-test, it will automatically send an OTAA join request. When the red LED changes from flashing to solid, the device has successfully joined the LoRaWAN network. After the device has joined the network, place one of our beacon devices near the CP34 master. The CP34 master will automatically scan for nearby beacon devices and upload the collected data to the LoRaWAN gateway. While the green LED is flashing, the device is actively transmitting data. Next, return to the TTN console, click Applications, open the application you created earlier, and select the registered end device. On the live data page, you can monitor the device's real-time communication, including join requests, uplink messages, and downlink messages. If these messages are displayed correctly, it confirms that the CP34 master has successfully joined the LoRaWAN network and is communicating properly with the TTN cloud server. This completes the LoRaWAN end device configuration and OTAA network activation process.